Investigate vertical transformation. Describe the transformation and sketch the graph of each transformed function, state, domain, and range. So we have three different parts here. A is a reciprocal function, then we have absolute function, and a parabola, a polynomial with degree 2. Well, this is for you to practice. I will do one of them so that I teach you the method of doing it. When we are talking about transformations, transformations could be vertical or horizontal, right? So that is how the transformations are. In general, let me tell you one thing here, and that is I'll write this general formula for transformation. That is, we could write transformation like this: a times f of k times x minus p plus q, right? So that is kind of a transformed function. And in this transformed function, outside points, this we call inside. These are my outside points, a and q. These are outside the function which is inside. This is what I'm saying, function of something here, right? So this inside function leads to horizontal transformations, whether they are horizontally compressed or stretched or translations. And these corresponds to vertical. So this is like vertical translation, right? And this one is vertical stretch or compression. So remember that part. So whenever it is outside the main function, then it is referring to vertical transformation. Here in these examples, we are multiplying by something to the main function. So we are doing it from outside. So minus 2 really refers to vertical. Half refers to vertical, minus half refers to vertical only. So all these three examples are for vertical transformations, and they are stretch or reflection. Minus means reflection. Less than 1 means vertically compressed, and more than 1, like 2, will mean vertically stretched. So basically, if you see, we have a reflection on x-axis, which is also vertical because the graph moves vertical. Do you see that? 2 is a vertical stretch, and half here is a vertical compression by a factor of half. Minus is reflection on x-axis, and half is vertical compression by a factor of half. So that is how you need to explain your transformations, right? This is just to give you an idea. Then when we are talking about investigate vertical transformations, then what are we really looking at, right? So we are looking at things outside the main function. When we talk about horizontal transformations, we'll be looking into factors inside, k and this p. K will be horizontal stretch or compression, and p will be horizontal translation left or right. Okay, let's get back to the main thing. So I would like to do at least one of them for you, and I'll choose to do C for you, which is h of x equals to minus half x squared. Rest to do it yourself, right? Okay, now, well, when in this particular function, h of x equals to minus half x squared, first thing is plot x squared. You can make table of values for any of these functions. The approach is kind of like this. These are your parent functions: parabola, absolute function, and square root function. So sketch your function. Now parabola, x squared starts with the vertex at origin, and then the critical points are 1, 1, right? And at 2 it is 4. So 1, 2, 3, 4, right? And at 3, so it's at 1, 2, 3, it is 9. 3 square is 9. So you get 1, 2, 3, 4, 5, 6, 7, 8, 9. So there you are. Now, important thing in parabola is it is symmetric, even function. So it's symmetric about y-axis. So you can put those points straight away here. So 3 goes 1, 2, 3, and you have your points. So that is your, I should say, the parent function, right? So we should always sketch this in light color. So let's say we have this parabola here, and let me just join these points with kind of a good graph, right? So okay, this is what it is. Note that we should not have a point here. It should be a rounded thing here when we are making a parabola, right? That's the first part. So I'm trying to show you how to sketch your graph graphically. I mean, transformations, how to show your transformations on the graph without the help of, point calculation. Now the next step is, whenever you're doing sketching, you should move left to right. So when I strike from left to right, I get this minus here. So let's do minus. That means the reflection on x-axis. So when this point gets reflected, it comes here, right? This is 4 away. So when it comes here, it goes to minus 4. So 1, 2, 3, 4. So you get 1, 2, 3, 4. And from the symmetry, you can put the other point. And third is 9. So we are already at 4. 5, 6, 7, 8, 9. So you're at the edge. There you are, right? So once you get this, join them. So what have we done so far? So first thing which we did was we sketched our parent function x squared. And then what did we do? We did the first step, which is minus of x squared, right? So this is minus x squared, this graph which we have. So we reflected this graph, and let me write down now the steps. That is the transformations which I am doing. We have two transformations here which we'll do in order. The first one is reflection on x-axis, and the second one is vertical compression by a factor of half. Correct? So you have to write by a factor of, because you get things multiplied by half, right? So it's a factor of half. So we have done the first part, vertical, that means vertical reflection on the x-axis. And the second is vertical compression. It's like pushing it, right? When you push it from here, then it's vertical compression. Basically, when we say by a factor of half, then x points remain same, all the y points, their value gets multiplied by half. That means it gets reduced, right? So I'll draw my final graph now, doing this final correction, which is half. So we do half of this point and we get that half. So half of 4 is 2. There we are. Half of 9 is 4.5. This is 4 for us. 4.5 is right there. So from symmetry, we get our points. So these are our points to be joined, and which will reflect transform function which we're trying to sketch here. So there you are. So we get like this and draw arrows. Don't think that this is the last point is the last point on your graph. The range is what? All real numbers less than this, right? So that is my final graph, and I can write this as hx equals to minus half x squared, right? So that is my function h of x, correct? So this is my function h of x. So that is how you have to sketch your function. Now you could have done with points also. Now let me show you with points how to do any graph for that matter with points. So let us say this is my function, original function, which is x squared, right? So in x squared, critical points are, as we suggested, is 0, 0. You start from here. Then as you go up and down, 1, 1, 2, 4, 3, 9, and so on. And then we have minus 1, 1, minus 2, and 4. These are my points on parent function x squared. Now the transformation here is that the x points remain same, since we have only vertical transformation. Here the x remains same. So what is basically happening is that my points which are x, y on the original function, they get transformed. The x points remain same, but the y points get multiplied by minus half of my y points, the original y points. So that is what is happening in h of x. So my h of x function therefore will have these points changed. We call them image. So image of these points will be x will remain same, but y will be minus half of the original y. So we get the point as minus 2. So we'll have x point same as minus 2, but we'll do half of 4, which is 2, and make it minus. So minus half. At this minus 1, we expect a value of minus half, right? At 0, we expect a value of minus half times 0 will give you 0 itself. And at 1, we expect a value of minus half. And at 2, we expect a value of 4 times minus half, which is minus 2. So these are your transform points. It's a good idea to check whether these points fall on your final graph or not, right? So that is kind of a check. But either way, you could have started like this, transformed your points, and plot these points straight on the graph. So both the approaches are correct approaches, and do as needed. Now one question is left now, state domain and range. As you know, in this function, what is the domain? Domain is all real numbers, right? It remains the same since x points are exactly what they were, right? So they didn't change. So domain range remains same. So we'll write for, I'm writing for h of x. So we say domain is x belongs to real numbers. Now how about range? Now as far as range is concerned, you have seen that it is reflected, and that reflection changes the range from greater than to less than. So we have ranges that y belongs to real numbers, but y is less than equal to 0. Is that okay? So that is the range, which you can also see from the graph. So that completes our work on this. So I'll suggest do other graphs also in a similar fashion. So if, for example, you are doing square root of x, you know square root of x will be kind of like this. Minus 2 means it gets reflected like this and then stretched by a factor of 2. There will be more coming downwards, right? So that is how you have to think and sketch your graph. I hope that helps. Thanks and all the best.